just wait. Okay. Yes. So there is a specific concept in preposition logic. You have heard about this topic. If you haven't, just think about this topic called implication in this. Okay, so this is called implication. That is specifically a part of discrete mathematics topic, preposition logic. Okay, so preposition logic is again a very good topic. If you seen this, is it's a kind of a language that computer understands now. Okay, so what have done in this preposition logic, that you have seen something language like every A is followed by B, like this language. If I go to school, then I will get attendance. These type of sentences that you have studied in this preposition logic. Okay, so if you haven't, so don't worry about it. I will tell you what this sign implication means. So this is a basic sign that depends upon if and then statement. Okay, so if something is going to happen and this is the implication of it, then something is supposed to happen again. Okay, so if I just say if I just go to a wedding, then I will congratulate the couple. Okay, so another example will be if I go out in the rain, I will get wet. Okay, so if I jump in the rain, if I jump in the what you say river, then I will get wet. Okay, so the truth table of this implication is indicated by this. If you seen the truth table here, 0 0 0 1 1 1 and 1 0. So basically where the keyword 1 0 lies, and it is only false in this, in everything it is true. Okay, so this is the truth table of implication. If you do not know how this comes, just remember this part because there's a detail why this happens and why every truth table has a different outcome. So just remember this 100. Okay, so in implication 100 is there. Apart from it, all the combinations are true here. Okay, so if I just do it in a statement like this, if I just say if this first sentence represent some action that is done by me, and the outcome of this is represented by the second truth table. Okay, so if I just say the action, suppose I say if I jump, if I jump in the river, then I will get wet. Okay, so this first part is your action if you jump in the river, and the second part is the outcome of that action. Okay, so this now if you read this table carefully, what will happen? It says that this say that the action here is if I jump in the river, and the outcome here is then I will get wet. Okay, so please replace these statements. Okay, now the 0 here means I haven't jumped in the river and I haven't get wet. Okay, so that is a true statement, because if I do not jump in the river, then I will not get wet. So that is a true statement. So that is why it's written here as true. Okay, so the second one is again I haven't jumped in the river, but I again get wet. So this is again a true statement. Okay, so you will think that how it is a true statement, that if I do not jump in the river, how will I get wet? So you can get wet by another like rain, by another reason that is not the part of this statement. So that is one of the most point to understand here, that you can get wet by like rain, by not getting in the river. There are other possible combinations that you can get. That is why this statement is true. Okay, so if I do not if I do not jump in the river, I can still get wet by other means, like going into the rain. Okay, so that is why this statement is true. Again, this section here, it says if I jump in the river, I will get wet. So this is a true statement, and this is the main statement of this implication is here. It is written like this as if I jump in the river, I will not get wet. So this is a false statement. It cannot happen. If you jump in the river, you will always get wet. Okay, so this is a basic introduction that you have seen this in quite detail in discrete mathematics, the keyword here implication. Okay, so now if you see this question, it only talks about the uh, if in which every A has to be followed by a B. Okay, so it means that if A comes, it has to be followed by a B, and nothing is given like if A do not come, what will happen? If only B come, then what will happen? So for that particular scenarios, anything is not defined here. Okay, so for that you will go for this implication truth table. Okay, so if I just write the implication truth table, you will be able to derive the number of strings that will be possible in the language. Okay, so you know the possible strings will be like AB will always be possible. This is the smallest string, but there can be other strings that are not exactly defined in this language. But if you apply this, apply this the concept of implication, you will again find that there are other strings that are there in the language, but you are not aware of it. Okay, so if I just write it in the implication form, so this is AB and this is the truth table. So there will be the value here. What will be the value? Okay, so 0, 0 go with this 0, 0, 0, 1, 1, 1 and 1, 0. Okay, so you remember the truth table, only 1, 0 is 0, all the inputs are 1. Okay, so now just recite it in the keywords here. You will understand more clearly that what I want to say. Okay, so this A means that A has come, and this B means that A will come or not. Okay, so if this A is 0, it means A has not come. If this B is 0, it means B has not come. If this B is 1, it means that B has come. And if this A is 1, it means that A has come. Okay, so just clearly look at this. Now, what is the first statement? It says that A has not come and B has not come, and this statement is again true. Okay, so it means that this language lie in this language. This string lies in this language, and the string will be A has not come and B has not come, and the input alphabet only consists of A and B. It means the string epsilon will again lie in this. Okay, yes, any doubt? Okay, so now see the second one. It says A has not come, B has come, and this is the true statement. Okay, so it means the string that only contain B's are also possible in this. The strings that only contain B's are also possible in this. And the third one says that A has come and B has come. So this is the most obvious thing, that A and B should lie in the language. If a come, B has to be get followed by it. Be it a 1B, it has to be, if any A comes, it has to be followed by B. It can be 1B, it can be more than 1B, but it is again satisfying the condition that uh, it is following A here. Again, if A comes, it has to be followed by B. Okay, so this string lies. Now this statement say if A comes and B does not come, so this is a false statement. This string will not lie in your language. Okay, so it is say if A comes and B does not come, so this string should not lie in your language. Okay, so by the use of this implication, there is also epsilon lie in this language. Okay, so by looking only at the question, I was not aware of this thing, that epsilon can also be a part of this language. But by applying the implication, I just made aware of that epsilon can also be in this. Okay, I am also not aware that only the B's can also lie in this language. So any number of B's can also lie in this language. Okay, so these if you apply this implication thing, that A in which every A is followed by B. So if you read it, it's like if A then B. Okay, so if A then B. So I have done nothing, just write a table of the implication. Okay, so this is only a pure discrete mathematic subject concept that you already studied. Okay, so preposition logic is again very useful in your English language too. If you understand preposition logic, you will also understand English language very carefully. There are many because Logic is like a language uh, invented to understand our English language to the computer. Okay, so this preposition logic contains the syntax and semantic of the English language in like mathematical notation. Okay, so if you understand this preposition logic language, your English language will also become very strong. Okay, so now you are aware of the language. Now you can easily draw the automata of it. Okay, so please try to draw the automata of this language again. Okay, so again I will write another string also. If any a come, any number of b's can come. Again, if a come, it has to be followed by a b. Okay, so try to draw the automata and please share the screenshot. After that we will go towards the new topic called NFV. Okay, again if you have any doubt you can ask. Okay, Aryan, you can get my phone number. Okay, I will post you at the end of the lecture my phone number for any queries. Okay, so don't worry about it, Aryan. I will tell you the my phone number. Okay, I think that is the previous queries asked by Aryan. Okay, I will post my phone number. Also, again, you can directly share your concerns and doubts directly to me on Microsoft chat also. Okay, so I have replied like in 5 or 10 minutes to students that have asked me any question. Okay, so I will also be available 24/7 on Microsoft team also. Okay, so again, okay, Fanindra, there is a string called AB. After A, there is again AAB. Okay, so you have made. Okay. So I just understand right now. What? Okay, that is correct. Okay. So the automata drawn by Fanindra is absolutely correct. So firstly, I did not understand the loop. Okay. Another automata drawn by a Mayank. Yes, Mayank, it's absolutely correct. So well done. I think you understand my point. So automata construction again became very easy if you just follow the steps that I have again discussed in the tute as well as in the lectures also. So go for the smallest string if you can. Okay. So the first string is the epsilon string. So again, you know that you have to make the initial state as final. Okay, so q naught. After that, smallest string if is your main string is your a followed by a b here. Okay, so a followed by a b here. Again, the smallest string after epsilon is b. So I want to accept any number of b's. You should just do a self loop of b. So any number of b's can be accepted. Okay, so and after that, the smallest string is ab. So a has to be followed by a b. Okay, so it can be written like this also. A has to be followed by a B, and it is a Q1 and Q2 language. Okay, so now in this, now I have to check a transition symbol. So transition symbol on Q node, A and B is defined. On Q1, A is not defined. On Q2, already A and B is not defined. So this state is incomplete. Only this state is complete, and this state is not complete. Okay. So what will I do if I just do a self loop of A here? So there is a possibility that AAB can also come. So this is wrong. I do not want that. I want that after a it has to be exactly followed by a b here. Okay, so what do I do? I can I can put this string into a dead state here. Again, if I comes, it doesn't bother the b here. So if I just do it a dead state qd, again it will happen. Okay, in the same way, now a is defined, b is defined here, so this state is complete. For q2, again after ab, I do not need to worry about it. Any number of b's can come. Okay, any number of b's can come. I do not need to worry about it. But again, if a come, I just want to make sure that B should all again come here. Okay. So again, if A come, so if I just do this type of a diversion here, so again after AB, any number of B's can come. I will again always land on Q2. Okay, so A is followed by B. This condition is satisfied. Again in Q2, if A come, okay, so I will go towards Q1 and only after getting the input of B, I can go to the Q2, which is a final state. Okay, so I think that is the correct transformation and that is the correct transition. Okay, and so check on Q2, A and B is also defined. Okay, in the same way, this is not a minimal automata. So what by following the steps that I have said that for was to build the smallest string and then go on. You can get this automata. This automata is again correct, but this automata can also be minimized. Okay. So again, if you do not understand how to minimize it, I will just again draw the minimized automata again. That is drawn by that is in your chat box drawn by Fanindra and Mayank here. So that is the minimal automata. So that automata is Q naught. So this is also a correct automata. That is why I'm trying. This is the minimal automata that is possible. Okay. So if you see what they have done is they do not want to draw two final states. So they just diverted that string to B. So the concept is same. After A comes, we need a input of B to reach to the final state. Okay. So this is again the minimal automata. Okay. So again, to the true transform from this to this is very easy. We just have to use a minimization algorithm that I will explain you how to do it. Okay, so if you are still at this stage that you are drawing this kind of automata, this is not wrong, this is correct, but the minimal one is this automata. So again, I'm again repeating a key concept here. There can be multiple DFAs. There can be multiple DFAs for a language, but there is only one minimal DFA for a particular language. Okay, so if I want to draw a minimal DFA, everyone will get this DFA as answer. But if I do not give a condition to draw a minimal DFA, the answer for everybody will be different. Okay, okay. So I think you understand it. You can again find. I will again give you the questions related to this, the variations of this in the tutorial 2. Okay, so you do not need to worry about that variety of question also. Okay, so I just want to explain that type of question also comes in this. Again, if you have any kind of doubt, you can ask me. So this implication that why it is that why it is 100, I cannot explain you because this is the part of core preposition logic and that will take time. Okay, so just keep in mind that please remember this truth table if you do not remember the concept why it is that. Okay, so 100, just remember this thing. Okay, okay. So our next topic is our NFA. So I just open the PPT of NFA. Okay. So we have studied DFA, and you find DFA to be a uh, quite structural approach towards building of efficient automatas. Okay, so if you have seen DFA, that there is one thing called a transition symbol, and that transition symbol is called Q into E. Sorry, the sign is this. Q into E belongs to a set of states. So this states that the transition on a set of state, like if I say the set of state of this, the transition of Q node on all the input has to define, and this will be only a one transition. It means to say that Q node on A will have only one state. Okay, it will transition it only to one state Q1, and Q node on B, it will again transition to only one state Q1 or Q2. Okay, so but in NFA there is a bit different. Everything is very similar to DFA. There is only one property the different property here. Okay, if you see the formal definition of NDFA, it says that it is represented by 5 tuple, and you will find that these 5 tuples, this is a set of state, and this is your input alphabet, and this is your transition symbol, and this is the starting state, and this is the final state. You will find that uh, it it if you look at these 5 tuples and you remember the DFA 5 tuples, and both of these tuples are equal. Okay, so now what is the difference here? If you see, the transition symbol is different here. Only the difference that lies in NFA is the transition symbol. Okay, so again, DFA is much more structured approach. Okay, so I just want to use the word structured. Okay, so DFA is one most structured approach, because I know that if I standing at any state, I know that for receiving a particular input, I am going into a particular state here. So this is much more structured than NFA. Now, if I say NFA, if you remember the concept of non-determinism that I have tell you in the starting, that on receiving this is a particular person, that person receiving an input of 10 rupees, it is going towards to buy a candy, and again after receiving an input of 10 rupees, and it can again this person can go on to buy or deposit this into a bank. Okay, so these on the same on the if you see on the same input, so 10 is the same input, it is going towards different state, but in DFA it cannot happen. If I say that if a person receives a 10 rupee, I am confirmed that it will go towards and buy a candy here. So this DFA, that is why I am saying that this DFA is much more structured, and you do not have to worry about the all the inputs on every state. But in this particular NFA, so it just says, if you look at the transition symbol here, it says Q into the set of states. This input alphabet, it goes to the power set of Q. So this, you remember the power set of Q. If you remember the set theory, in that if this is the set like A, this set contains only one element, and the power set of A will be 2 raised to power the number of elements. The number of elements here is 1. So the power set of this is this contains 2 number of elements. So the power set of suppose this say set 1. So the power set of this set is, you have to remember it, it will contain 5 and the complete set. Okay, so if you remember the power set, so this is 2 raised to power Q is the power set here. So it says that on receiving an input, if I just again, if I just tell you what I mean clearly, I just take a help of this. Again, I just draw example of NFA. Okay, so the example of NFA is pretty straightforward. This is the example that I want to use, that it ends with A. Okay, so I want to design a automata. You have done this, ends with A, start with A, contains A. So these type of question you have done it too. Okay, so you have to take care in case of an NFA. Suppose this is an NFA. Now this NFA says that on Q node any number of A's and B's can come, and it is ending with A. I just want to make sure. Okay, so this is ending with A, Q node, Q1. So if you see this NFA, this is fairly very easy NFA. The input, if you see this on Q node, on receiving an input of A, it is staying at Q node, as well as on receiving an input of A, it is going towards Q1. Okay, so these the on Q node on receiving an input of A, it can go towards 2 different states, as well as if you see that on Q1 there is no symbol, yeah, no input alphabet defined. Okay, so this is an example of NFA. I will tell you how to draw it, so don't worry about it right now. Okay, so now you remember the 5 tuple symbols. The 5 tuple symbols are Q here. Q is what? The set of states. So in this particular example, the set of states is Q1, Q0 and Q1. and epsilon is what the input here. So input here in this is particularly A and B. F is the final state, and in this the final state is Q1. Another symbol Q naught. Q naught is the starting state. So in this the starting state is in Q. The transition symbol here is again remember it that Q into set of this input symbol raised to power 2 raised to power Q. Okay. Now see this. What do I mean by this? That
Oh fucking if we start this side.
hello. Is there any kind of doubt? Okay, so if you clearly look at this thing, I just want to say that Q into E raised to power set. So what do I mean by this? This means that Q here in this particular example, Q is what? Q1 and Q naught. And what is the input here? Input is A comma B. Okay. Now the power set here is it says 2 raised to power. What are the number of states? 2. Okay, so it says that it can go towards a total four four states. Now the four states will be, if I just, this is again the power set here. So what is the power set of this q power set of this? Okay, so the power set of this will be, the first is q naught, second is q1, the third is phi, this is also called your null set, and the fourth is q naught and q1. Okay, so I again have to complete take the all the terms. Okay, so it is saying that upon receiving a transition from q naught to q1, q naught to a, q naught to b, it can go towards these four states. Okay, so q naught to ab and q1 to a and q1 to b. Okay, if you see now there is an introduction of something called a dead configuration. So it is a dead configuration. Okay, upon receiving an input of something, if it is not going anywhere, then it means that it is going towards the null state. Okay, so if you see in this automata, on receiving on q naught, after receiving an input of a, the transition is towards q naught as well as on q1. So it will go towards q naught as well as towards q1. On receiving an input of b on q naught, it is staying at q naught. It is staying at q naught. On receiving an input of a on q1, it is not defined here. So it means that it is going towards the dead configuration. Again, on receiving an input of B on Q1, again it is not defined. Okay, so these are the kind of possible outcomes that are possible by using this transition symbol. It just says that now there is no compulsion that for every state you have to define the input alphabet. See here, this here A and B is not defined. Okay, so if you see to build a NFA, you just have to take care that if you are landing in this Q1 state, your string will be accepted. If you are not landing in this Q1 state, your string will be rejected. Okay, so if I say a string that is ending with a, like A, B, and A. Okay, so if you scan it, like if I again say that after that B will come, you will think that this string should not be accepted, but it ends with b, so it should not be accepted. So I just go with the first example that it should end with a. Okay, so now this is ending with a, so just check it. Upon receiving an input of a on q naught, it is staying at q naught. Upon receiving an input of a on q naught, it is again stayed at q naught. A, q naught, a, q naught, b, q naught, a, it goes towards the final state and it just stayed there. So it means that this string is in the language. But now what happened if I say a, b? Okay, so this is ending with b, should not be in the language here. So if you see a, upon receiving an input of a on q naught, it is staying at q naught. Upon receiving an input of a on q naught, it is staying at q naught. It can go towards this again. It's the will of the user. It can stay here, or it can go towards it. So suppose in the first scenario it is staying at q naught. So I just say that upon receiving an input of a, it stayed at q naught, and upon receiving an input of b, it stayed at q naught. So this string is not accepted. So another, so if I just write it, it will be more clearer. So Q naught on A is staying at Q naught. Okay. Q naught on receiving an input of A is staying at Q naught. After that, again A come. Q naught on receiving an input of A is staying at Q naught, and again it can go towards Q1 here. Okay. So I just want to follow one path here. Okay. So I'm just concentrating on this path. Okay. So again, after receiving an input of B, it is staying at Q naught. So this is not a final state. It means that this symbol is not accepted. Again, if you see this again, that on Q1, it is now at Q1. On receiving an input of B on Q1, it is not defined here. So this is a dead configuration. What happens? Q1 on B is not defined. So if you land in a dead configuration, it again means that this string does not lie in the language. Okay. So this, so do not get confused in it. So again, you will find it quite a confusing thing than NFA, because it is not as much structured, but it is very easy to build. Okay, so there is no compulsion to define every input on every state, and you can give you can again define multiple the same input on various transitions also. Okay, if you see it clearly, the same input A is defined on two transitions here. So transition on Q node on A, transition. Just wait.
Sir, if any path reaches the final state, then we say that it is in the language,
Yes,
right?
if any path that leads to the final state, then it lies
Okay,
in the
sir.
language.
Okay, sir.
That path is defined, it means in this case it means that it doesn't lie in the language. Okay, so in DFA, if you remember it, if any path that leads to the end of the final state, the string lies in the language. Now the definition was, if it is does not if the string does not reach to the final state, then the language is not accepted. If the string reach in the final state, the language is accepted in case of DFA. Now here the definition is different. If you land in the final path, again the definition is same here. The string will be accepted and it is in the language. But if you do not land in the final path, as well as if you land in a dead configuration, the string is again not accepted. Okay, so I just want to say these two things.
No, sir, if some path leads to the final state and if some path leads to some another path,
Okay, so
and
you
so,
take the path that leads to the final state. So that is more convenient. Okay,
okay,
so
sir.
there is a choice here. Okay, so if you see
Okay.
it clearly, DFA, every path is defined in DFA, every path. But if you see in NFA, every path is not defined, then there can be multiple paths for same input. Okay, multiple path can be possible. So the real application of this NFA, if you see, is in multitask processing. So if you see multitasking in your, and if you see in your GPU, like multi-threading. So multi-threading is the application of this NFA. So it just can take on the similar output, can take different paths, and it will, if you say that on if your desired, if you have studied AI, right, again you are studied AI in your, I think in this semester only, and you will find something called search algorithms in that. So search algorithm, what will do? They again take different paths on the same input. Okay. So the path which leads to the path that leads to the final goal state, that the thing is called goal state, and it just take a least amount of cost. Okay, so that path is considered your best path. Okay, so in this AI also, so the application of this NFA is again in AI path searching, in multi-threading, and in various other domains. I will again explain you that. Okay, so again if I just switch in here. Okay. Okay, so this the PPT, all of the things are written like this that I have explained to you. Okay, so if you see, this is the example of this NFA that I have explained. Now see clearly here the input alphabet is only A. Okay, it just says that A is accepted here. Okay, because it leads to the final state. But if you take another path for A, only A, it is rejected if it lands at Q1, and it is also rejected if it lands at Q3. Okay, so Q3 here is dead configuration. There is no input defined. Again, it is not a final state here. Okay, so if I just land if I just follow the path, this path A is accepted here. But if I follow the path here, this is again the second path A. I just land for receiving an input of A on Q0. I will go to Q3, and on Q3 the transition of A is not defined. So this is again a dead configuration. Okay, so you reach a dead configuration, it means the string is not accepted if you follow this path. Okay, okay, okay. So again, there is something very interesting in this called epsilon transition. Okay, so what is the meaning of epsilon transition? That if you are at any state, and in DFA this is not possible. So just remember this. What I am telling you are the features of NFA. In DFA this is not possible. Okay, so DFA epsilon moves are not possible. So epsilon moves are also called epsilon transitions. Okay, so if you quite look at it, what is the epsilon move here? So if you are at any state and you just want to move to the final state or any other state, if I just want to move to Q2, so for that, if you see clearly in every DFA, you have to give a symbol here like A or B or B or A. But there is also another set here that if you want to just move it to the another state without giving any input or defining any input, you can use this epsilon. Okay, so the epsilon, you remember, this is called a null string. It means that upon receiving an input of nothing, this q node can move to q1 as well as q2. Okay, so if you reach like this state is connected to like q4 q3 here. Okay, again if you reach at this q3, and again there is a transition from q3, that transition of q3 from A, you reach to q node. Okay, so if you just remember that this state is not defined, so do not consider this. Okay, so on a transition of Q3, on getting an input of A, it leads to Q2. It is as good as saying that it is leading to the final state. Okay, so again there is no need for Q node. There is no kind of input available here. So this is a null string. So you can, if you reach this state, you can again move it to Q1. It depends upon you. Okay, so it is as good as saying that you reached the final state, but the final state is Q1. Okay. Okay, so if you see any state with an epsilon transition to an accepting state ends up working like an accepting states too. Okay, so it is saying that any state with the epsilon transition to an accepting state. So this Q node uh, it Q node contains a epsilon moves towards the accepting state here. Okay, so that is why if you reach at Q node, it is as good as saying that you have reached the final state. Okay, so we do not use this epsilon transition very oftenly. So there are very small cases that we use this. If you see this case, okay, so this specifically used for combining various kinds of automatas. Okay, so if I just give you an example of it, that the union operator, that this is the example of union operator where this epsilon moves are used. Okay, so see this is a star where n is odd. Okay, so this is the same thing that we have drawn. Okay, so in this particular thing, this is a NFA. Again, remember this in NFA, and we have defined the input of A and B. Okay, so we have not defined B here, so do not need to worry about it because this is a NFA and we do not need to define every symbol here. So This is for odd and this is again B for odd. If you want to combine these two states by something called a union of automatas, you can do like this. Okay, so you just draw initial state and that just give a epsilon moves to it and you are just combining these two automatas. Okay, so there is no complexity needed. These epsilon move are only used in union operators. Okay, so if you want to combine two automatas to do a union of it. Okay, so again this is not very much important because this is just a use case that we use, but more oftenly we just try to avoid using the epsilon here. So for a very good epsilon understanding, there is something we have defined a epsilon NFA differently. Okay, so for that we will again, if you remember the finite automata with output, without output, there are three types. Okay, so the first type without output, the first type was DFA, and the second type was NFA, and the third type was epsilon NFA. So most of the functionality of epsilon NFA is defined more clearly in this, and there are very few applications of epsilon in this NFA. But just remember that you can do a epsilon move in NFA also. Epsilon moves are possible in NFA, but it is not possible in DFA. So if you see this, that DFA is much more structured than NFA, and we know that what is going to happen in DFA. Okay, so going on further, these are some differences. I think you read about this. This is fairly easy and readable. Okay, so just read about it, all the differences that lies in DFA and NFA. It is defined in this table, and these are all very simple. If you just look at it, you will understand it. Okay, now just start with the questions here. Okay, so if you just draw this question, this is again a very fairly easy question. Now for NFA, everything becomes so much easy to draw here. Okay, so if I just open one node, I just tell you that how it is easy, so much easy. Okay, okay, so this is the first question. It just says we want a string that starts with A. Okay, so if you remember this, first step is always write the language here. So the language, it should start with A. Okay, so A is the smallest string, A, B, 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 anything can come. Okay, so if I just write a regular expression of it, it just means that it should starts with A, and after that any number of A and B's can come. Okay, so if I just now regular expression is much more clear in this NFA. If you design it now, it says that I have to design NFA here, and because this is a permanent thing because we want our string to start with A, so we have to write it on an arrow here. Okay, so after that any number of A's and B's can come. So this is your NFA, so not need to worry about that we have to define B on this starting state. You just go with this. Okay, so every symbol like this symbol B, A should not be accepted because it is starting with B. So on Q node, B is not defined, so it is a dead configuration. So you can directly say that this doesn't lie in the language. So by doing this, if you see, we are saving some time and we are saving some space. Okay, we are saving some time also, and we are saving space also, that we do not have to store every move for every possible output input here. Okay, so I think you understand this question. If I just do a bit quickly this question, I again think you easily understand this. Again, if I do this second question again says it only contains A. So the language for it will be that it only contains A. So A is the smallest, and it can contain A anywhere in the middle and in the end here. So those whose tutorial is today can again understand it very clearly that what I am doing, because we just have done this the question for DFA in the tutorial also. Okay, so again, if you write the regular expression of it, it just say it should contain A. Before any number of A and B's can come, after any number of B and A can come, but it just contain A here, so that has to be permanent. Okay, if I define it in a NFA, it becomes so much easy that this A After that, any number of A and B's can come. Okay, so this is how this NFA becomes so much easy to draw. Okay, so I think you get the point here. Again, if you just to understand that you have understood that what I have said, please and draw this question and post your drawn question in the chat box here. Okay, please remember to write draw this arrow to the starting state. Okay, again, if you have any doubt, you can ask.
Sir, I have a doubt.
Yes, yes, please.
Sir, basically, there was one slide in which the example of NFA was given for one single alphabet A.
Yes, yes.
So can you please move to that slide once?
Yeah. This is a slide, I think. Okay, can you see it?
Yes, sir. Yes, sir. Sir, इसमें so both Q1 and Q2 will be both Q1 and Q3 will be the dead state, right?
Q1 and Q3. You
Because
cannot say it like a dead state. This Q1 is a state, but Q3 is a state that has a dead configuration. I will say dead configuration because A and B is not defined there. Okay.
okay.
Okay, so dead state, if you remember the concept of dead state, it is just like so it is just like that you get a input something and you just stay there. So this is the concept of dead state. Okay.
Okay. Okay. Okay.
Okay, what was the question?
Sir, that's it. So my question was ki, like if you move on to Q1, so like so the input will not be accepted, right?
Yes, 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 sure, sure.
Okay, okay, okay.
If you move on to Q3, your input will not be accepted. That is what you are asking now?
So last thing, like if I give the input as AA, so how
Yeah,
will
yeah.
we know like, that will be going to the first part and not the second one? So
Okay,
so, so
so
50-50 percent chance of accepting, right?
okay, yes, you can say it that we have 50-50 chance of acceptance because you can follow any path here. So the path where your acceptance is occurring, we will follow only that path. That is the advantage of this, that we have defined multiple paths and we will follow only that path where our input is accepting. Okay,
Okay, okay. So got it, sir. Okay, sir. Thank
that
you.
is the advantage of it. Okay, I think Anirudh, all of you have drawn a correct automata. So the automata was to ending with the AB, ending with A. Ah, yes. So correctly, if you just write a regular expression of it, I just know any number of A and B's can come, but it should always end with A. Okay. So if I just if you draw the language also, any number of A, the smallest is this A, it ends with A. Any number of A and B's can come after, always ends with A. So for this, you again remember that this is kind of a self loop here. A and B can come. Again, we do not have any compulsion that we have to define A only once. Okay. So again, if you define like this, I think that's okay. There is no need to draw any kind of a self loop or another thing on Q1 here. So I think all of you like Anirudh, Amit, Chahat has drawn the correct automata, including Mayank and Fanindra. Okay, so good. I think you understand the concept here of NFA. So Now you will be thinking that there are certain advantages of NFA over DFA. Okay, so there are certain advantages like NFA takes less space. Why less space? Because we do not have to define the definition of input is not there on every state. Okay, definition of input on every state is not compulsion. This is not a compulsion, but it takes more space and time because it takes the definition of each and every, but it is much more structured than NFA. Okay, so if I just using a DFA, I am much more certain which path to take for a particular input. So this DFA provides us more certainty than this NFA, and again NFA is very easy to draw and it is just a difficult thing to draw. Okay, so they both have their advantages and disadvantages, and most of you will be saying that if you see that NFA is equal to or is greater than or DFA, if I say that NFA has more expressive power than DFA, then this is the wrong statement. Okay, so expressive power of both NFA and DFA are equivalent. Okay, so every DFA, for if I just say it can be represented in a diagram like this, that the DFA is a subset of NFA. So if you clearly look at this diagram, so don't get confused in this diagram, it says every DFA is a NFA, but every NFA is not a DFA. Okay, so if you remember the statement of NFA very clearly, NFA just says that we do not have a compulsion to define all the state. There is a word called compulsion. Okay, so it depends upon the choice of the user. Again, you can define. Okay, so if you are defining A and B on Q0 on Q1, I will again can say that this is a DFA as well as an NFA. Okay, so everything is similar. If you see this diagram, every DFA is a NFA, but every NFA is not a DFA because there are some NFA lies here that does not contain in the DFA part. Okay, so that you have studied. So if you remember, if you have studied Venn diagram, okay, so if I just say this A, B and C here, so I can say that every A is B and C. Okay, I can say this. For B, I can say every B is C, but every C is not B. Okay, so if you remember the concept of a Venn diagram, so just remember this statement clearly that NFA is equivalent to DFA. Okay, so if you have drawn a NFA, it can be converted into a DFA. Okay, so it can be converted into a DFA by something called a subset construction method. I will just discuss this method in the next class. Okay, so for certainty, if you require those, suppose if in the exam I cannot give you to draw like a NFA because NFA has nothing like structured. If I just want to ask you question like I have given you a certain DFA and please tell me the number of states. So this is the question that I can ask you in exam. Okay, so I always want that the number of states will in DFA is certain, and minimal DFA everybody will get the same answer. Okay, so I can ask you this question that please give me a minimal DFA. You know that NFA is very easy to draw. You can convert this into a DFA again. And if you want to check it that you got the minimum number of state, you can go towards the minimization algorithm to reduce the number of states. So every time you will receive a minimal DFA. Okay, so if you are attempting competitive exams like GATE and NET, okay, they will always give you a very confusing question, and it in the first look that question seems very easy, but what happens is that If you directly try to draw a DFA, you will always get a number of states as more or less than the asked question. So always, if you are attempting in an exam, always draw a NFA of a state, then convert this NFA into a DFA, and then minimize this DFA. Okay, so that is the correct way to attempt a question in difficult exams like GATE and NET. Okay, so you should follow this approach if you are giving any exam. But for our theory practices that we will not be doing it like that. You can again draw simple automata like a straight DFA. Okay, so in the next class we will discuss the subset set construction, that how to convert the NFA to DFA. Again, if you have any doubt, you can ask me and you can send me. I will again share you my number also. Okay, so thank you for listening, and you
Sir,
can tune in your next class. Yes, yes,
sir,
please.
sir,
Yes, yes,
actually, I'm not understanding one thing, that in NFA, when we are putting a self loop on Q0,
yes,
A
yes,
and B, both of like suppose the input is a single A, it will stop on Q0,
yes, yes.
and like since the input is only A, so Q0 will be a dead state and it will not like accept it.
Yes, yes, you are absolutely right. But here are two transition possible. The first transition is on Q node and the second transition on Q1. So I will always take that transition that will land in a uh, uh, final state. Okay. So I know that A and B is possible on Q node also. I can land in this state, but I can also land in this state. So always land in that state that benefit us. Okay. So that is the figure of speech here. Okay,
So,
you
but then
understand?
what is the point of providing a state which we don't want to land on?
What is the?
Like, what is the point of keeping such a state in like which we want to avoid?
Okay, so you can get rid of that state again. Again, if you get rid of the state, you can also get rid of the state. Do not need to worry about it. But here now, like another strings like A, B will not be accepted in. So you have to again draw a DFA for that, and that DFA is again a NFA. You can also go with that. Okay. So if I want to say that why I am drawing this transition symbol of input of A on two different multiple path we can take. So always take the path that benefit you. Okay, so in our, if you are studying what do I say? If you are studying state search algorithms in your AI, again you will go in different paths. Okay, so again getting an input like 1010 or 1010, you will again go on a different paths that are possible, but you will always take a path that will benefit you. Okay, so if suppose this is a goal and this is also a goal that you have reached, but in these two states you do not reach a goal state. Okay, so this is another state app. So I will take that path only where a goal state is possible. So that is why in say in NFA there is something called backtracking is also possible. So why there is a backtracking? Because I can go back and see which state is best for my thing. If you studied the algorithm backtracking in data structures, also in AI this is also used. Okay.
Yes, okay.
Okay. So thank you for listening. You can tune in your next lecture.